Here's a few disassembly hints. Now the units that we got to disassemble were from a Jeep Renegade and a Range Rover and a couple of others, but for this webinar we're just going to go over some of the Jeep Renegade and the Range Rover unit. Now the Range Rover that we received was a prototype. The case was badly busted up so that the transmission couldn't be reused. So some of the photos will be from the Renegade and from the Range Rover. What you see here is a two-wheel drive Jeep Renegade. The TCM is located right there on top, just above the differential. And that's basically where you'll find it on most units. Correction on that, I believe this is the one that does have the all-wheel drive case. I just noticed the bolt holes, as you can see here on the front of the bell housing. These are the bolt hookups for the power takeoff unit. Now, the electronic connector is located on the side cover on this transmission. This is the Renegade. And you'll see that before you can pull the cover off, there's this clip that has to be removed that holds the connector in place. We'll have to remove that clip first. Then the connector will be able to push down inside the cover, and then the cover can be removed. Now on the Range Rover, we found that the connector was actually going through at the top of the case instead of the side cover. And you can see that this case was broken up pretty bad so that it wasn't going to be reused. But we wanted to show you the difference on some of the imports versus the domestic vehicles. So the case connector is going to be in this area, whether it's going through the case or through the side cover. You still have to remove the retainer so that we can push the connector down into the transmission. Now after removing the TCM and the side cover, we started on the valve body next. Now this is on the Renegade. There's 10 bolts that have larger torque size heads, and those are the only bolts that have to be removed. And you can see with the close-up picture to the right, some of the other Torx bolts are much smaller, so we only need to remove the ones with the larger head. Now on the Range Rover, there's only 8 bolts that have to be removed. Again, they'll have the same larger type Torx head on them. We found it much easier to go ahead and cut the wire tie that we're showing you here. Once that wire tie was cut, it was easier to swing the whole valve body out of the way. And then later on, we unbolted the speed sensors and the rain sensor and left everything as one assembly. Now, with the valve body removed, you'll see that there's 8 aluminum feed tubes found underneath the valve body. And this was on the Renegade. And there's 2 tubes that feed the F dog clutch that are kind of unique in their shape. They're round at one end and then they're oblong on the other end. And you can see in the case exactly where they go. This one particular aluminum tube stayed with the valve body. That goes right there where the filter feed is, the intake for the filter. Now on the Range Rover, it was a little bit different. It's the same layout, except 2 of the tubes were plastic. And you can see those there. And as you can see, the rest of the tubes are aluminum. And we have the same 2 unique shaped ones that feed the F dog clutch. Now we went to the front of the transmission and we had to remove this bracket. This is on the all-wheel drive Renegade. So with that bracket out of the way, we could go ahead and remove all the bolts that hold the bell housing down to the main case. At this point, we left all the bolts inside the bell housing in place. We wanted to remove just the bell housing with all the components that bolted to it from the other side. We found it much easier this way. Now you can see the bell housing on the left and the main case on the right. With the bell housing off, you can see we have the output gear and the E-clutch assembly that's bolted right here. And here's our internal filter. Underneath the filter, you can't see it at this point, but it's the off-access pump very similar to what we've seen in the other ZF transmissions, whether it's the ZF6 or the ZF8, same type of pump. Now on the main case side, you can see we have the differential, the transfer and pinion gear, and then you can see the P3, P4 sun gear located here with the planets. Now with the belt housing off and out of the way, we can just go ahead and lift the differential right out, no problem there. Same thing with the transfer and pinion gear. They lift right out of the case, no problem at all. Want a little closer look at the P3, P4 sun gear sitting on the P3, P4 planet, which you're looking at here. These are the synchro teeth that synchronize this F dog clutch, and we'll go over that a little bit later on in the webinar. Now the two planets can be removed. The first one will be the P4 planet here, and they lifts right out, and then we can lift out the P3 planet, as you can see here on the right. Now before you can go any further, we're going to have to get a small socket to put the tip of our pulling tool right here. And this will just need a regular bearing puller tool that go ahead and pull that bearing right off the case. It comes off pretty easy, not too tough. It's not on that tight. It's a press fit, but it's not on as tight as you would think it would be. It's pretty easy to get that off. Now with that out of the way, we'll begin to remove the D clutch housing and the piston. And that you can see right here on the right. That's the housing we need to remove next. Now, Bill Brayton came up with a pretty cool little toolkit that he made up, as well as some tools that we actually had to purchase for disassembling this transmission. Now, he was using a couple of pieces of steel plate, some bolts, and he actually took a 4L80E fourth clutch housing, and we cut that down as a spacer, which made up his compression toolkit. And this was to help remove and install the snap ring for the D clutch housing and piston assembly. Now this is one tough snap ring to remove without it, because you see here there's a lip that goes actually along this housing, and the lip keeps the snap ring in that location for the groove. Now the bevel return spring that you see here on the right is extremely strong. It makes it really difficult to push down by hand, push the housing down by hand far enough to pry the snap ring out. Now, I'm not saying it can't be done. This can be done without compressing it just to remove it. But it's much easier with the tool, and there's no chance of damaging that lip that I mentioned that goes around the housing. The reason that I'm mentioning it is we did remove one without compressing it, and we actually caused some damage to that lip that goes around the housing, so it's much better to use the tool to remove that assembly, and way easier to put it back in by compressing it. So you can see here's the tool that he made up. He's got a plate, drilled a couple of holes that line up with the case, that we could bolt it down and hold it in place. Then he threaded a couple other holes here, and cut a hole out of the center for the input shaft. Now with our two bolts, we can take another piece of steel just as a push down. And there's our 4L80E drum cut down as a spacer to be able to push down on that housing. So now we can go around and just take that snap ring out. And you can see that little edge that I'm talking about in different sections on the housing. We didn't want to damage that. Once all that's been compressed and the snap ring's out, you can see everything comes out together, no problem at all. Now there is a special tool that you can purchase. The tool number is in your handout. It's 8901A. And at the time that we were purchasing this tool, we got it online. The only attachments for it were the short adapters you see here on the right. Now they show the picture on the left of the tool sold with the long adapters. We weren't able to get those, so we just went to a hardware store and got a few lengths of 1/2-inch threaded rod, and we fixed that problem right away. So we used the threaded rod for long adapters. Now the tool on eBay that we purchased, and we've seen other prices anywhere from $35 to $82. Again, the ones that we saw only came with the short attachments, so you can go ahead and purchase that online. Now, the tools to install and remove the D-clutch housing, piston assembly, and snap ring, and we're showing you here. It's a couple of 3/8-inch steel plates. Cut the hole out in the center, as you can see on both of them. And these are pretty stout plates. Using the 16-inch piece of steel plate, we put that next to the center of the plate, and then we marked the case where we needed to drill our holes for a couple of hold-down bolts. And that's what you're looking at there on the right. Then we drilled and tapped a couple of 3/8 holes. Then we were able to use those long bolts, and you can see how we compressed that. And we also had a 4-inch by 8-inch piece of steel, a hole punched out in the middle of that as well. I believe we sent that out to a machine shop to cut that for us. You can use longer bolts for this, in case to put this down in the bottom of it. The case, we're going to be using the same type of setup, but we just used the 4L80 housing to make up the distance for a spacer. Pretty good, because this tool can just stay on the bench, much easier to work with. You could actually take this over to the press and try to press that piston down and take the snap ring out that way. We found it much easier to do this on the bench. Now the B driving clutch assembly can be lifted out of the case once we remove that D clutch housing assembly. And now we can get to the D and C brake clutch, as well as the P2 planet and the P1 planet. Now when the B driving clutch assembly is taken out, you'll see that the bearing that sits at the bottom of the housing, and that's the housing you're looking at right here, as well as the D and C brake clutch hub that you see here, which also has the ring gear in it, and this is the actual P2 planet. You'll also find that the P1, P2 planet here is actually sitting on top of this. So that's all part of the assembly. That all lifts right out together. Now here's a couple of pictures from the Range Rover used as an example. As you can see, they look quite similar. They're practically the same. The parts are not interchangeable. Now we just removed the snap ring from the P3 ring gear just to show you that it does come off separately. And then the P1 sun gear and P1 ring gears assembly you can see there on the right. On the other side of the P2 sun gear and P1 ring gear is where you'll find the synchronizer teeth that are found for the A dog clutch. And we'll go into that function a little bit later on in the webinar. Now we can go ahead and remove the P1, P2 planet assembly on the right. And you can see there's a thrust bearing that sits right here on top of that planet. And then all we have to do is just lift off the P2 ring gear and the P1 sun gear. Again, mentioning that bearing at the bottom of the B clutch drum, we don't want to lose that. Make sure that goes back just the way you see it. And then what we did is we removed the A dog clutch and the input shaft right from the drum itself. We wanted to give you a different view, or a closer view, on how the piston works that A dog clutch. So this is the A dog clutch here. We took the retaining pin out, and we just snap ring actually holds that whole assembly in the drum. Now what happens here is the piston moves the A dog clutch back and forth to synchronize the teeth inside the P2 sun gear and P1 ring gear. That's what we're looking at here. These are the synchro teeth for the A dog clutch synchro teeth here. So this shaft doesn't move, this ring gear doesn't move. Basically that A clutch will move back and forth on the shaft hydraulically to apply that A dog clutch. So this is another ratio they can obtain without the use of a clutch to apply and release this. So they don't have any frictions. They just use the actual gears to change the ratio. Now on the right, with the gear removed, inside the shaft you can see the piston, and this is where the pin would go through, so it allows the gear only to move back and forth that small amount. Now, when engaged, oil pressure will flow in at the end of the shaft, and it will move the dog clutch assembly upward. So oil pressure will come up through here and move this gear up. That'll engage into the other ring gear, and that's how we'll get that shift to happen. Now, all the hydraulics we covered previously in the introduction webinar. So there's your B clutch, A dog clutch sitting here, upward is engaged, and then to disengage it, it goes downward. Now the oil pressure will come in between these two sealing rings, and that will be the release pressure for the A dog clutch. Now on the bottom of the case, you can see in that ring tower to the right, there's a sealing ring that holds the applied pressure here. So the oil pressure will actually come out here, go into the back of the shaft, and that sealing would sit right there in that groove, and that's what would be the seal. Now in the back of the shaft there's a hole, and this is like a metal clad seal. Very difficult to remove it without damaging it. So we left it in there because we want to do some air checks on this. Now the hole you see here in between these two O-rings, that's the oil pressure that's going to come out and actually apply the B clutch. We found that all the sealing rings on this transmission were the Torlon finger joint type rings. Now keep in mind we have to be careful when we remove and assemble these rings back in their locations. We try not to distort them in any way. That type of material has very bad memory. It doesn't conform back to its original shape too well. So if we damage that or distort that ring in any way, whether you're reusing the old ones or even putting on new ones, whether they're aftermarket or OE, any distortion to that ring, it will not seal correctly. Now we flip the B clutch drum over, and we're going to go ahead and compress the bevel return spring and remove the snap ring that we're showing you here on the left. Now the clearance that we measured on this prototype, this is the one from the Range Rover, was about 60 thousandths. As you can see, with all the clutches removed, we have a wave plate, a steel plate here, and then we have a pressure plate at the end. And there's our return spring underneath the piston. And I mean, there's O-rings on this piston, which is like a balance piston, and then we have our our beveled return spring here. Now, if you look at the stack up, you can see that the oil pressure is applied on the left between these two sealing rings here. These are actually rubber rings. And what will happen is the oil pressure will come in between the two pistons. So actually this piston is the oil pressure is trying to push it up, which actually pushes this piston down because that one's stationary, and that will compress our beveled return spring, and that's how we actually apply the clutch from this side. Okay, after we've gone through that B clutch drum assembly, we'll see that the next set of clutches that'll lift right out of the case. There's no more retainers here for this clutch assembly. That's the D brake clutch that you see here on the left. The next thing that we have to remove is the retainer snap ring for the C brake clutch assembly, and we're showing you that here on the right. One of the things I want to point out is the C brake clutch retainer snap ring opening, and it has to align to this tab that you see right here. There's a small tab on the pressure plate that faces up, and we have to make sure that the opening of the snap ring is on both sides of that tab. Now the end plane on the Range Rover prototype was about 35 thousandths. Obviously this can vary from model to model, and we'll have more information on this transmission at Expo, as well as our upcoming rebuild book that Bill is working on as we speak. So we're going to have more information on end plays and end play checks through that information. Now we're going to look at the tool that we set up and use for the C clutch piston retainer snap ring. Now taking the snap ring out for the C clutch piston was not too difficult at all. Basically you could just pop it out of place. There was nothing that could be damaged. The biggest problem is when it's time to install the snap ring. the bevel return spring in this area is extremely strong. So it would be very difficult to get the snap ring back in just trying to use brute force. So the second tool we had to bite the bullet, and we found it on the internet. We didn't have any resources to cut a piece of 3/8 inch steel plate into such a design as you see here on the right. So this is a Miller tool. You have the number in your handout. It's 10504. And it's called the C-clutch spring compressor. And you can find this on the website anywhere for around 90 bucks. Now we can still use our crossbar instead of having the hassle of taking the case over to the press. So this time we used the reverse reaction drum, often referred to as the cookie cutter or the stovepipe, and that was from a 4T65E. Now we used a smaller crossbar from previous fabricating special tools, so we just have that same crossbar to use using the shell as the spacer, and we pushed it down on top of that tool that you see to the right. And on the right here you can see the same setup we had before, except now we're using this stovepipe with the special Miller tool so we can compress that to put the snap ring back in. Now one of the things I want to mention here is this this type of snap ring is an L shape to it. If you look closely here, you see there's a ridge that goes all the way around, so it's like an L-shaped snap ring. Now the snap ring opening for the snap ring, you can see it's got those two curved ends to it. Now it has to align with the opened area at the top of the case as we're showing you here on the left. Last thing we want to point out is there's a thrust bearing that goes underneath that B clutch drum, and also you can see that there's a shim for that bearing right here in the case. We want to make sure we don't mislocate that and make sure that it goes back in place. Okay, now it's time for the bell housing section. Just go ahead and flip the bell housing over. We're going to remove all the retaining bolts inside the bell housing so that now we can get to the transfer gear, the pump, and the E-clutch assembly. And that's what you're looking at over here on the other photo. It has the internal filter, and the pump is located underneath that filter. And you can see the transfer gear section there also. One of the things we like to point out at this point in time is the input and output speed sensors. Now the input speed sensor actually monitors that row of windows that you see there on the E-clutch drum. So the input speed sensor is going to be looking right here through that hole, and it's going to be looking at these windows that go by it on the E-clutch drum. The output speed sensor kind of aligns with this opening here, and it just monitors the teeth on the output gear. Now, the E-clutch drum is actually splined to the input shaft, and it turns with the torque converter. So when the engine's running, that drum is also turning. As you can see, here's the E-clutch drum. Here's our windows for the input speed sensor. That's splined directly to the input shaft. This shaft is always turning with engine speed. Now, the actual E-clutch hub, that's splined right here into the P3 planet. This is the P4 planet. We pulled it up out of the way to get a better view down in there. We're using these photos from the Range Rover, the same as the one in the Renegade. So when the E-clutch is applied, the E-clutch hub is actually driving that P3 planet. Next thing we need to remove is the feed tube that you see here. There's a sealing ring on each end of that. Make sure that those get replaced during overhaul. Now with the tube out of the way, you can see we can go ahead and take off the output gear housing. I took a photo of the other side of the housing to give you an idea of what it looks like. Now on this housing, on this output gear housing, what I want to point out here is the P3, P4 sun gear is stationary. That's the sun gear you're looking at here. We showed that earlier where we just lifted it out from the two planets that are in there. So that sun gear is stationary, stays in place, it doesn't move forward or backward. Now, what you do have is the F dog clutch is located here. Now, when we applied air into this left tube, it actually moved the F dog clutch upward and it engaged the teeth with the P3, P4 sun gear. Blew air in on this side, pulls the gear down, and that disengages that clutch. Just giving you a closer view to see how the teeth will mesh. We actually took the F dog clutch out of the housing, and you can see there's a couple of O-rings that go on the housing itself. There's also another one located here inside the support. Then we simply just remove the E-clutch hub, and we can take the E-clutch assembly right out of the housing, which I call the stator support. And we also still have the off-access pump located here. As you can see, we have some more bolts we're going to have to remove from this support and also from the housing. We went ahead and removed all the bolts. We took the stator support out. Underneath that support there's a shim, and that shim will sit right here on top of the drive gear for the chain. Then we lifted off the sprocket support, or the sprocket cover. You can see this is our binary pump, and there's our drive sprocket located there. Now, it sounds much easier than it is to really actually do this, but you need to push down slightly on this pump assembly to take some tension off the actual snap ring that holds it in place. Once we squeeze the two ends together and relieve some of the pressure, it will come up just a little bit, but you may have to pry on these three tabs to get the pump to start coming up where you can let the snap ring go. Again, like I said, it sounds easier than it really is. It's a little tricky to do this. But once we got it up enough that the snap ring would not go back into the groove, you have to basically keep going around, prying up on these tabs, and you have to be careful here because you can break these. So we kind of walked it out of the bore. Once it was out, you can see what the assembly looks like here on the right. We have a couple more O-rings for seals. Now this off-access pump is basically the same type you'll find on any of the other ZF rear-wheel drives, whether it's the ZF8 rather, rear-wheel drive, but it's not interchangeable. But it's very similar to what we've seen before. It just, in this application, there's some slight differences. It has the same type of spring plate located here. You have to put just a little bit of pressure on this. We take that E-clip out. And as you can see, here's our spring plate. You have a couple of tabs that have to line up with these notches. Underneath that plate, you'll see that there's an O-ring that goes here as a seal. As we started to disassemble the rest of it, you can see we got the cover out of the way. There's a couple of alignment pins that go here for the body. The cover is aluminum, the body is steel. You see we have quite a few vanes and the rotor. Now, in order to remove the rotor, there's another small snap ring here. Once that's removed, we can take the rotor off the driven sprocket, and that the driven sprocket will come out from the other side. And that's pretty much it to hold the pump assembly together. Now, this is the E-clutch drum disassembly. There's a molded piston, as you can see here on the right. This should be changed during overhaul. We found the same thing on both the Renegade and the Range Rover. They were pretty much identical as far as the assembly layout. You can see there's a race here and a thrust bearing. So once we compressed the bevel spring, took the snap ring out, everything came right out of it. A couple things I want to point out. There's also an inner molded seal and we carefully pried this off to give you a better look of how it is. You want to make sure that when we do put a new one here that we press this down evenly, so you're probably going to want to put some kind of a ring or something or a plate to be able to push this down evenly. But the metal that it's made of is pretty tinny. It wouldn't take much to distort it, so you want to be careful when you reassemble that. And what we're showing you here is the other side of that thrust bearing. The open end side faces down on this race. Here's a complete exploded view of the E-clutch assembly layout. On our prototype, we found that the clutch end play was about 50 thousandths. So there's our thrust bearing assembly, our snap ring, the bevel return spring retainer, the return spring itself, the molded piston. You can see the inner molded seal here. And there's our exciter windows for the input speed sensor. Now there's two types of valve bodies that can be found on any model, whether it's the Jeep or the Range Rover. There's a manual shift valve body. You'll find that that one has 9 solenoids. And you'll have a limp home mode solenoid and one to control pressure. All the rest of the solenoids are named for what they do. So each solenoid will control a clutch that you see here. Now the valve body has an identification tag on it. This is going to be important. I'm sure just like anything else we've dealt with on these later model vehicles, we start changing these solenoids. Even though the color of the connector is the same, these solenoids all have different flow rates. So if we're going to reuse them, we should mark where they came from, make sure they go back where we started out. If they are changed, you'll probably have to do some type of a software update to the TCM for any changes to the valve body or the solenoids. This is still the Jeep Renegade. You can see we have this pressure transducer that's mounted on the valve body. Now this is used by the TCM to monitor the release pressure of both dog clutches. So when one of the dog clutches releases, there's a momentary increase in dog clutch exhaust circuit pressure. So now the transducer will signal that pattern, and it's monitored by the TCM to control the apply and release of the clutch, as well as for diagnostics, whether the clutch is not applied or slipping. That information is all going to be used by the TCM. As you can see here on the right, it's got 5 volts going to it. It's going to have a signal wire and a ground. It's very similar to any type of a TPS setup. Very similar also to the Chrysler rear-wheel drives, the transducer that monitors governor pressure. It basically works the same way. So this is still the Jeep Renegade, the manual shift valve body. These are the small part locations. And you can see we have 2 alignment pins. They're a little bit thinner at one end than they are at the other. Those will sit right down inside the casting of the valve body here. And we have 1 rubber check ball in the bathtub. And then on the there's a large red check valve for the spring. There'll be 2 black check valves with springs. And then 1 more large blue check valve. And then you'll find this small check valve here that has a red plastic tip on it. This is something we should be familiar with on the ZF8s, the silk screen separator plate. Obviously, if any damage is done to the silk screen, the plate either has to be replaced. What some technicians are doing on the ZF8 rear-wheel drives, basically they'll heat that plate up in the parts washer. They'll lay it down on a flat piece of granite. They'll take a flat stone. They won't use any type of a wheel to take that material off. You want to make sure that that's flat if you do want to do it that way. You have to use a flat stone. Keep everything flat. Make sure we flat stone all the valve body halves, torque everything to spec, and you shouldn't have a problem reusing the plate that way. Obviously, the best way to do this would be to replace the plate. Okay, this is the valve layout and the solenoids for the lower valve body. You have all the solenoids and the valves identified for you in your handout. This is the upper valve body exploded view. You can see we have that limp home mode valve here. And then we have all the clutch valves. Now, we used the Range Rover for this information here. This is the E-shift valve body. You can see we have the added solenoids, so there'll be 10 solenoids here. This is a mechanical park solenoid. It's not, there's no hydraulic pressure here. It's just basically used to control the rod to pull it in and out of park. You can see this was ID'd. It's made in Germany. Some other identification numbers on that also. And you'll find that the rest of the solenoids are similar, although we don't have that limp home mode. This is a park control solenoid. That's going to hydraulically help move this cylinder to remove it out of park and obviously hold it in park. Just like we saw in the Renegade, same type of setup. You have the transducer that monitors the release pressure for both dog clutches. The small parts that we found in the E-shift valve body is slightly different. We still have the same 2 alignment pins. All the check valves seem to be about the same. The only thing with this valve body, there's no small check valve with the red cap on it. What I did find interesting on this one is they don't use a rubber check ball in this bathtub. They use this rocker ball. It's not something new. It's something that they've done with quite a few ZFs. I personally feel that this is much better. We don't have a ball rotating and moving back and forth inside the bore that could cause the check ball to wear down. So I think this is a much better idea. We also have a silk screen separator plate, different color on the silk screen, but basically the same setup. And you also have the lower valve body exploded view, and we give you all the valves identification here also. And this is the upper valve body. Not much different. Now, as far as the back cover goes, which is the last part of the transmission that we worked with, we're using the Range Rover here as an example. We found 2 small covers on the back. We removed one of them, and basically there's just a gasket out in there to control the separating of the hydraulic circuits here. Our tube was missing on this one, but there is a tube that goes from this section downward to here. You'll see that on the next one. We show you the Renegade, which has the same type of tube. And then we removed the small back cover that we found here, and there was a small O-ring over the center hole, and then another gasket located there. Now here's the back of the Renegade, pretty similar. Only difference here is we had the rear cover. This tube wasn't missing. So it gives you an idea what that tube looks like. And then you'll notice here it does not have the small back cover. That was the only difference that we found on the Renegade. Now, in this photo, I happen to be showing you the 2-wheel drive model, but I just wanted to point out that some models that you find may have a cooler warmer on it. So obviously they'll use the heated water from the radiator to go through this and actually heat up the transmission fluid at first to get it up to operating temperature quicker. Once it reaches a certain temperature, there'll be a valve that controls the water circuit from the radiator, and then they'll use the cooling water to cool down the transmission fluid. On the all-wheel drives, you'll find this power transfer unit here. This is the side that would go in towards the seal, and this is just the picture of the back of it. We also have for you the case air checks. Once the transmission's all assembled with the valve body still off, you have all the case air checks that you can actually go in and do all your air checks before we do final assembly of the valve body.